Hey guys, in this video we are going to be building this 120 watt LED light panel which is inspired from the LED sky panels. Enough of the intro, let's get started.
For this project, we are going to use a material called sunboard. 5 or 6 mm thick sheets of sunboard can be used as it is a friendly material to work with as well as being structurally strong at the same time. The big sheet needs to be cut in these specific dimensions which can be found in the description, and they can be cut using a simple paper knife. On one of the 650 by 180 mm sheet, we need to cut out 2 vents for the fans. I just used the fans as a template and used a paper knife to cut out the vents. On one of the 650 by 180 mm sheet, we need the top vent. You can get the printout in the description for free and cut exactly on the guidelines and stick them together using some glue stick. In a similar way, apply glue to the back of the template and stick it onto the sunboard. Critical measurements are not required over here, so I roughly stuck it on to the top side of the board. And using this little tiny X-Acto knife, I'll be cutting it out. This took a very long time, but it's worth the wait because it gives the light a professional look. After a thorough cleanup with some water, here's how it looks. Next up, we have the aluminum plate on which the LEDs themselves are going to be mounted on. Long story short, I wasn't able to find the right size of the aluminum sheet, so I'm using another piece of sunboard on the top and bottom as a padding so that it can be mounted properly on the chassis of the light panel. Now using some Fevikwik or cyanoacrylate glue, I'm sticking the sunboard onto the aluminum sheet. These are the LEDs that I'll be using for the light panel. 20 of those are warm white or 6000 Kelvin in temperature. The other 20 are natural white or 4000 Kelvin in temperature. Here I'm spraying some isopropyl alcohol on the aluminum sheet followed by a good wipe. This is done to remove any oil stains or fingerprints that are present on the aluminum sheet. And now I'm marking these exact points as shown on screen. All the plans and templates are available in the description for free. The same cyanoacrylate glue can be used to stick these LEDs onto the aluminum sheet. The glue has good thermal conductivity and it's not going to reach very high temperatures, so it's perfect to use for this specific application. Keep in mind the orientation of the LEDs, the letters must face you. 40 LEDs later, here I'm soldering some wires so that power can be supplied to them. This is the exact replica of the wiring diagram that you are viewing here. These are the side panels and they need a structural support which needs to be cut out from 5 mm thick plywood. Dimensions and templates can be found in the description. I'm roughly drawing a 3 cm square at the center, and that's because no glue should be present within this area and it can be stuck onto the sunboard using some hot glue. The center needs to be drilled with a 6 mm drill bit. These are the various mounting hardware that I made from 19 mm thick sheets of wood. These are the tightening and loosening knobs. This is what will hold the light onto the light stand. This is a square piece of plywood with a nut inserted in it. And finally, a square piece of plywood with a 6 mm hole in the center. Now we need to take that piece and clamp it in this way using a nut and a bolt. It can be used as a template to mark out where the sunboard needs to be cut, and using a paper knife I cut out the sunboard. Now on the sunboard side, the blank piece of plywood can be placed with some wood glue. Now on the other side, the piece with the nut can be placed with the nut facing outwards, and all of them can be clamped in place using the bolt. The whole process needs to be repeated once again for the other side. All the pieces of sunboard can be stuck together with copious amounts of cyanoacrylate glue, and here I am using these little pieces as structural support, and once everything is glued in place, it feels pretty solid. Placing the LED panel on top of the chassis, we can see that it doesn't fit properly, and that's because we need to cut out 2 slots over here as shown in the drawing. After cutting out the slots, which is something that I should have done earlier, it fits properly. For mounting purposes, we need to drill 2 holes on the bottom and 2 holes on the top as shown in the drawing. And now 4 screws can be used to mount the panel. For the threads of the screw to bite into, we need to make these wedges out of 3 layers of sunboard, and they can be stuck in place using some cyanoacrylate glue. For cable management, 2 holes can be drilled near the endings of the wires and the wires can be routed through them. Now using 4 screws, the light panel can be fixed onto the chassis, and once that's done, everything feels really solid. For making the stand, the plan is to use some 1-inch diameter CPVC tube along with 2 elbow joints and a T-joint to mount it on a readily available light stand. Those bulb-like looking pieces of plywood go on one side of the shorter CPVC tube and attach on either side of the LED panel using the bolt. This is the part which connects the LED panel onto the light stand, and it needs to be machined on a lathe, dimensions to which can be found in the description. It has a tightening screw on the side so that the light doesn't wobble around when mounted on the stand. 2 tubes of 21 cm length and 2 tubes of 31 cm length needs to be cut out. These 2 pieces of plywood needs to be glued on the 21 cm length pipes. Using the L joint, one longer pipe and the other shorter pipe needs to be joined in this way. And the same process has to be repeated for the other side. Before attaching the T-joint, we need to glue the steel piece in place using some cyanoacrylate glue. At this point, everything can be glued in place permanently using some CPVC cement. But I'd like to play around with the angle a little bit, so I'll be gluing them in later. And now onto the electronics. Ideally, we need two 1.6 kilo ohm resistors, but they are not available in the market, so 1 kilo ohm resistor should do good. We need 2 of these potentiometer knobs, a 230 volt on-off switch, a male power plug, a buck converter for the fan, 2 buck converters for the LEDs, 2 80mm fans, yes, I'm reusing them from another project, and finally a 12 volt and 15 amp power supply. We need to desolder this potentiometer from the buck converter. To do that, I'll just pull the 3 terminals with solder and then just pull it out. The same has to be done for the other buck converter as well, and the excess solder can be removed. Also note that if these 2 terminals are shorted, it's not going to cause any problem. Using a small piece of sunboard, I'm mounting these components in place using some screws. Using another piece of sunboard, this is going to be the control panel for the user. 2 holes for the potentiometer and 1 square hole for the switch, and they can be mounted in place with the knobs. Using a square piece of sunboard, the power jack can be mounted in place for extra structural strength. This is going to be the layout inside of the light panel. You can of course place them according to your preference. 2 slots needs to be cut for the user panel and the power jack, and using some Fevikwik, everything is mounted in place. For the power supply, I made a small mount out of some pieces of sunboard, and using 2 screws, it's mounted in place securely. For the wiring, we need to solder a black wire to the neutral terminal, a red wire to the live terminal, and a green/yellow wire to the earth terminal, and adding some heat shrinks for safety. The terminals are marked on the power supply, so we need to wire them accordingly: red, black, green to live, neutral, and earth respectively. On the output side, we have 2 negative terminals and 2 positive terminals. The red and black wires can be connected to one set of terminals, whereas the blue and white wires can be connected to the other set of terminals. On the buck converter, the outermost terminal is positive in, followed by negative in, negative out, and positive out. Since the white is positive and blue is negative, they can be connected in this way. And for the other converter, we need to twist an extra pair of wires to the wires that are coming from the power supply, and this will provide power to the fan controller, which can be soldered in place. I forgot to add the switch, so here I'm extending the red wire with some blue wire because I ran out of red wire, and then followed by a heat shrink. So the live wire can be soldered to any of the terminals of the switch, and another wire is soldered to the other terminal, which carries power back to the power supply. And now this wire can be fed as live to the power supply. Using the potentiometers that we desoldered earlier, the middle and the right leg of the potentiometer needs to be soldered to the rightmost terminal of the controller, and the same has to be done for the other converter as well. A twisted pair of wire can be soldered to the free leg and to the free terminal of the buck converter. On the other end, they need to be soldered to the middle and the right terminals of the potentiometer, and the exact same process can be repeated for the other converter. A pair of wire needs to be soldered to the other side of the fan controller, and then parallel connections are made to both of the fans, followed by heat shrinks to prevent shorts. Next, I'm hot gluing the fans in place, and I'm not using any filters or mesh over here, but if you want to install them, you can. Before turning on the light panel, all the potentiometers has to be turned anti-clockwise, except for those that are directly soldered on the 300 watt buck converter. Instead, they need to be turned all the way clockwise. After that, the light panel can be turned on and nothing happens. And that's because we have set the output voltage of all the controllers to 0. To get the fan spinning, turn the potentiometer of the fan controller clockwise until they start spinning, and set it at a point where there's good airflow without too much noise. I'm using blue and white wires to connect both sections of the LEDs to the controller because I ran out of red and black wires. After extending the wires originally coming out from the front, some heat shrink can be added, and to organize them I'm using some tape. A good length of wire is left so that the panel is easily accessible when maintenance is required. Now the ends of the wires can be connected to the voltage regulators. The light panel can be turned on, and as you can see, the LEDs are not lighting up. To set the operating voltage, turn the user potentiometer completely clockwise and then turn the potentiometer inside the LED panel clockwise until the LEDs have achieved the maximum brightness. To make sure that the LEDs can last a long time, the current that it draws needs to be set properly. To set it up, turn the amperage potentiometer completely anti-clockwise and then turn it clockwise again until the LEDs reach their maximum brightness and stop there. This was the setup for the warm white LEDs, and the same setup needs to be followed once again for the natural white LEDs.
So that is it guys, this is how you build your very own LED light panel. Of course, you don't have to stick to this specific design, you can modify it according to your needs. And if you make one of these, do post it on Instagram and tag me. This is my username. So that's it for the video guys, thumbs up this video if you liked it and subscribe to the channel for more such videos and tech reviews. Meet you in a future video. Thank you for watching.